Morning, everybody. We're going to finish up solving some equations today, and then we're going to take a look at some quadratics, the graphs of parabolas. So to finish up equations, I'm just going to reiterate ways to check your answers when you're solving equations. So the first thing before we get started is we need to get a little bit of terminology here. So the names of different types of equations that we're going to see in this class, as far as like polynomials go, we've got linear equations with the highest exponent of 1. We've got quadratic equations with the highest exponent of 2. We've got the cubic equations with the highest exponent of 3. Quartics, with the highest exponent of 4. So when we're referring to these polynomials, we use the degree to label them. So if the degree is just the highest number, the highest exponent in the problem. And the degree is important because the degree actually determines the possible number of real solutions. So like, for example, a linear equation, a degree 1 has at most one real solution. It only crosses the x-axis at most one time. A quadratic can have, I'm just going to use some ditto marks, at most 2 real solutions here. A cubic can have at most 3. A quartic can have at most 4, and so on and so forth. So the two ways that you can use technology to check these, obviously being able to do it by hand helps, but being able to check yourself is a valuable life skill, not just a math skill. So let's look at this again real quick. So the first way, we've looked at this before, but I just want to give us a refresher here, is we can solve it using technology by looking at it by graphing it. So if we go in here and we graph the left-hand side of this, come on, Mr. Price, squared, plus 4x, and we want to know where is this thing going to cross 7? Where is it going? Where's 2x squared plus 4x? When is it going to equal 7? What we can do is if we graph that, we can get those coordinates there. So that is, let's see, the x value of 1.12, that's approximately, and the other x value is approximately negative 3.12. Now, if you are not on if you're not using the app where you can just click, you will have to go second. You'll have to hit trace, and you'll have to hit enter 3 times near the intersection. Enter 3 times near that intersection. If you have any problems with that, just let me know and we can look at it together. So that's one way to solve these using technology. The other way, we haven't explicitly talked about this, is that we can use, if we go to apps here and you go to Polysmalt here and go to Polynomial Root Finder, what this will do is it will set up a polynomial based on the degree, and the calculator will actually go and solve that for you. So let's see here. Before we can do that, we've got to have this equation set equal to 0. So all that I'm going to do is I'm going to move. So we got x cubed, we've got plus 4x. I'm going to add the x over. That's 4x squared plus x minus 6 equals 0. So this is a polynomial. The highest exponent here is a 3. It is a cubic. And then what we'll do is go over to coefficients there. We're going to say 1, say 4, say 1, oh, nope, say 1, say negative 6, and then we're going to go over to solve that. So there's at most 3 real solutions that could work here. There's at most 3 real solutions that could work here. And so those solutions are that x could be 1. The second solution is that x could be negative 2 and make that equation work. And the third is that x could be negative 3 and make that equation work. And so all of those answers there would pop up if you graph this as well. That it would pop up on a graph as well. So either way that you want to work to solve polynomials will work using technology. So if you want to ever confirm an answer, those are two ways that you can do so. So we're going to go past solving equations now. We've spent the last couple of classes on that, and we're going to focus the second big picture for us is quadratic functions here. So a quadratic function you all probably studied extensively in Algebra 2. We're going to go just a little deeper with it. So again, a quadratic function is a graph, highest exponent of 2. It has a parabola shape, so it can either be facing upward or downward. And so we're going to go a little bit into those graphs for today. So the first thing here, for any value of x that we've got on a quadratic, you can evaluate it just by substituting in like you would with a regular function. So the first example here, and by the way, I guess I should have mentioned, this is in the orange book. The other two notes, the notes we just took in 4E are in the red book if you're trying to look at those at some point. So we're going to evaluate this just at different points. And you're probably like, Mr. Price, I can do this. If you can do it, go ahead and do it. Just pause the video and then fast forward to when this part is done. So we're just evaluating for different values of x here. So let's see, that's going to be y equals negative 2 times 0. That's going to be 0 plus 3 plus 1. So that's going to give me a y value of 4. So like the coordinate 0, 4 would be on there. We can do the same thing for 2. We'd say, all right, that's negative 2 times 2 squared plus 3 times 2 plus 1. Negative 2, let's see, 2 squared is 4. That'll be negative 8 plus 6 plus 1. That'll give us the y value of negative 1, which gives us a coordinate of 2 comma negative 1. Now, the other thing real quick, and why I wanted to go over this, is one of the most common mistakes that Mr. Price sees when students are substituting into quadratics. If you are just doing using a calculator to evaluate, which is fine, if you put in negative 3 squared and you don't have parentheses on that, it's going to give you two different answers here, because what this one is doing right here is it's squaring the 3 first. It's doing PEMDAS, and then it's going to throw a negative sign on it. But what we actually want to do is we want to say, okay, well, what is negative 3 times negative 3? If you're substituting in and you don't put parentheses, if you're trying to use a calculator to simplify that, it is not going to come out correctly. So this is negative 3 squared, that's 9. Negative 2 times 9 is negative 18. Let's see, 3 times negative 3 is minus 9. This is plus 1. We're going to get a y value of negative 26. So the coordinate that would work here is negative 3, negative 26. Now, also, so we can substitute in x values to see if we get a correct y value. We can also test whether a pair is on a parabola or if it satisfies a quadratic function by substituting in the x coordinate and seeing if we get the matching y coordinate. So what we can look at here, and I guess I need to write this coordinate here, negative 3 comma 1. So we're going to see if the coordinate 216 works for this function right here. Would it be on the graph? So we're going to substitute in the y value of 16 and the x value of 2. So let's see, times 2 squared plus 2 times 2. So that we're going to get 16 equals 2 squared is 4 times 3 is 12 plus 4. So if you end up with a correct equation here, we can say 216 is a point on the graph, and just verifying that real quick, that math works out for that point. And then for the other one, and then for the other one right here, we've got y equals negative x squared minus 2x plus 1. Again, we are going to substitute. We need to make sure to put this thing in parentheses when we are evaluating, because if we do not, minus 2 times negative 3 plus 1. If you're using a calculator, especially to evaluate this, we need to make sure that we evaluate it first. So let's see, negative 3 squared is positive 9 times the negative is negative 9 plus 6 plus 1. I'm going to get 1 equals negative 9 plus 7, which is going to give me a value of negative 2. So that does not work. So then negative 3, 1 is not a point on the graph. Now, working the other way, so we can substitute in x values, we can substitute in x and y values. Working backwards the other way here, if we want to see if what y value is going to produce an x value here, there's usually a little bit more math involved. So for example, if we said y equals x squared minus 2x plus 3, find the value of x when y equals 2. Well, if we do 2 equals x squared minus 2x plus 3, and this is an equation that we now want to solve. Remember, we just got out of a big equation solving section. So what we want to do is we want to say, okay, well, I'm going to subtract 2 from both sides here. X squared minus 2x plus 1. This has to be set equal to 0. Now, there's like 4 or 5 different ways that we could solve this. We could use polysmalt, we could use graphing, we could try to factor it, quadratic formula, we could complete the square. I'm just going to see if it factors real quick. I'm impartial to factoring. So let's see, we need things that multiply to 1 and add to negative 2. That'd be negative 1 and negative 1. So this would be x minus 1 times x minus 1. And if we set one of those equal to 0, we're going to get the x value of 1. So like the actual coordinate that would be on that graph right there would be the coordinate 1, 2. 1, 2. And so with that, all of that coordinate work that we just worked on helps us to create graphs of parabolas, because I'm sure we know the basic shape of a parabola, but we also need to have a mathematical understanding of where these shapes are coming from, why it looks like what it does, and how to generate those ourselves. And so all of these parabolas that we look at are based off of the simplest quadratic function, which is just you have a variable, which in this case we use x, and we square it. So we're gonna, whatever number we put in, we're going to multiply it by itself, and that's how we're going to get the y value. So like if we put in negative 3 times negative 3 is 9, negative 2 times negative 2 is 4, and so on and so forth. And if you plot those points and you connect those points, you end up getting a graph that looks like a U, and this is what we refer to as our parabola. So the general parent function, as this is called, has a it opens upward. It has a vertex right here at 0, 0, which is either going to be the highest point or the lowest point. Also, this is the turning point for the graph. The vertex, if it's the bottom, it's going from either increasing to decreasing or decreasing to increasing. And this is also symmetric across the x-axis. It's also symmetric across the x-axis. So let's take a look at drawing a graph of one that's not the perfect parent function here. So let's see. So a few things that you want to try to make sure when you're graphing something that you have encapsulated, that you have worked on. Let's see. So the one thing that you want to try to make sure that you do, the vertex of this thing is important. So like, where is the lowest or the highest point of this graph right here? You want to look at the x-intercepts. You want to try to make sure to get the y-intercept. So when we're graphing these things, if you have those, it's really easy to get a picture of what your graph is going to look like. You don't need a ton of points, but these are the things that we're going to be solving for today. So let's see. I'm just going to start punching in x values. So let's see. I'm going to do an x value of 0. That seems like the easiest because that's going to just take care of these things right here. So let's see. 0, that's going to be 0 minus 5. So that's going to be 0, negative 5. And what I'm going to do, 0 squared minus 2 times 0 minus 5. I'm going to show y'all a quicker trick to get these things plotted. So if you enter something in the calculator, if you hit second and enter, it's going to pull up exactly what you just typed in. So like if you have to evaluate some points here, you can just bring up your entry and then just change the x value. So like if I do 1, that's going to be negative 6. If I do 2 here, that's going to be negative 5. If I do 3 here, that's going to be negative 2. And let's go the other way as well. So let's do negative 1. And then I need to insert a parenthesis there. And then I need to insert a negative 1. So if I do negative 1, I get negative 2 as well. And then if I do let's see, we'll do negative 2. I think that should be enough points. I think that will encapsulate most of what's going on. If we do negative 2, we get a value of 3. So we're going to graph these points now. And let's see here. So we've got 0, 1, 2, 3, 4, negative 5. So there's a coordinate right there. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. Not perfect, but it will do. So we're going to go 1 and then down to negative 6. So that coordinate right there. We're going to go 2 down to negative 5. We're going to go 3, 1, 2, 3, down to negative 2. We're going to go negative 1 down to negative 2. And then we got also the coordinate negative 2, 1, 2, 3 right there. And so we can see if we connect these points, we're starting to get this graph, this shape of a parabola. And if you look here, if you're like, okay, wait a second, Mr. Price, you didn't get this coordinate up here. Since these things are symmetrical, there's an axis of symmetry here. I don't even have to plot that next point. If I look at the vertex, I'm like, okay, this coordinate is 1, 2, 3. Oh, that should be going through there at 1, excuse me. If this is 3 away from the axis of symmetry, 1, 2, 3, I'm just going to go 3 this way, 1, 2, 3. And plot them that way as well. So you don't even have, there's a bunch of different ways to evaluate these on a parabola. You don't have to necessarily plot every single point with algebra. You can use that property of it being symmetrical to figure that out. So then the last thing for today is the axis intercepts, the axes intercepts. And so mechanically, we want to look at how we find these things using algebra. So the y-intercept here, if you think about mathematically what a y-intercept is, The y-intercept is when it is crossing this axis right here, the y-axis. So if you pick any coordinate here on the y-axis, what you need to understand is that this is going to always have an x value of 0 for all of these because we are on the y-axis. All of those points have a y or an x value of 0. So the way using algebra that you're going to calculate a y-intercept is you're going to substitute in x equals 0. Now, if your quadratic is in standard form right here, which is what we kind of looked at before with the polysmalt, the ax squared plus bx plus c, your y-intercept is just going to be the constant c right there, because when we substitute in 0, a times 0 squared plus b times 0, that's going to be 0, that's going to be 0. All we're left with is the c. So algebraically, let's find a couple of y-intercepts real quick. So we've got two different parabolas here. We got one in standard form, and this form over here is what's called factored form because we're given the factors of it. So we're going to find both of these y-intercepts the same way. We're just going to substitute in an x value of 0 into these. So you can see again 2 times 0, 0, 0 plus 5. It ends up just being that c value. So this graph is going to cross the y-axis at the coordinate or at the value of 5. And then the other one, we're going to still set x equal to 0. 0 plus 3, 0 minus 6. That's going to be 3 times negative 6. And we're going to get a y-intercept of negative 18 there. Now, the same thing, but opposite, is true for the x-intercept. So x-intercepts, you think about a graph here. If something is crossing the x-axis, the same logic can be applied. It doesn't matter where it's crossing the x-axis. That tells us something about its y value. Its y value is going to be 0. So if you are trying to find the x-intercepts, you're going to set y equal to 0, and then you're going to solve your equation. And so when you're doing that, all that you've got to do is say, okay, well, I'm going to, if I've got my quadratic factored, I can use that 0 product property right here. If I've got it equal to 0, I'm going to try to factor it. If I can't factor it, I'll use quadratic formula, or I can use completing the square, or I could use technology. All this stuff we've been learning kind of ties together. So if I wanted to find the x-intercepts here, the last example for today, what I would do is say, okay, well, I'm trying to find the x-intercepts. So that means that y has to be equal to 0. And we need to be in the habit of saying these things to ourselves. Like if I'm trying to find the x-intercept, or if I'm trying to find the y-intercept, what does that tell me about something? Like what can I possibly get from this, or how can I do this? So for an x-intercept, we can set y equal to 0. And then we can set each of these factors. We can set each of these factors equal to 0. So we can say 0 equals 3, but that's never going to be true. That equation won't work out. We've got x minus 4 equals 0. We've got x plus 2 equals 0. So our x-intercepts here are going to be x equals 4 and x equals negative 2. So that is where we're going to stop for today. If you all have any questions, please let me know about quadratics or about solving equations, and we can definitely set some time to talk about those together. And other than that, I hope you all have been staying warm, and I hope you enjoyed your couple of days off. You all have a good weekend, and I will see you next week.